Okay, today I want to basically answer a question which I got on the CB Slack, where we discuss about the basically the scalability of CB in combination with Kafka and the Kafka Connect for CB. And what I started actually is I started a small project where I pulled together a couple of resources we already have for doing benchmarks and scalability tests. Um, on, in this case, Google Cloud. So we're basically using Kubernetes. So you should be able to use that on any cloud provider providing Kubernetes. And for this, what I basically want to do is I want to run more or less this example. That's the ping pong example from the Kafka Connect for CB, where I kick off workflow instances and then I use a Kafka Connect source to send something to a topic. And this is actually not yet implemented. Let's see if I come to that. But then some worker picks that up and just like pongs it again to another topic, which then is listened to by a Kafka Connect source. And then this is correlated to a waiting instance in CB, and the workflow moves on. That's more or less what the ping pong example already does. And I do that within Kubernetes. I basically start up a couple of CB nodes. I start up a couple of Kafka nodes. I have the CB gateway running here. Okay, this is actually the plan. It's not what I'm doing actually. So we better probably not look at that picture at all at the moment. I'm sorry. Right. So let me check. So what I wanted to check is, yes, my cluster is gone because I had to delete my cluster from earlier tries. And the idea is that it can follow along more or less this small README. So I already are authenticated to, in this case, G-Cloud, Google Cloud, and deserted my project. And then mm, there's a shell script. And if you wonder, you're using Windows, how do you run shell scripts? You're absolutely right, but that's awesome. I run the Linux subsystem. It's in Ubuntu on Windows, so that's no problem actually. So what I can do is I can run um, that shell script, setup cluster. You might have to, if you fork the repository, you might have to actually go into that and probably even adjust that to whatever you need. So in my case, it just uses the G-Cloud thingy to create a new cluster. Um, I use auto scaling with a maximum number of 32 nodes that allows me to make relatively big tests with these machines. Um, right in Europe West 1, because that's like the nearest for me here in Germany. Um, so that's it. Then what I do is I basically install Tiller, which I need for Helm. I do a couple of things for security. Then as soon as Helm is installed, I install Prometheus. I installed Grafana. That's kind of the default setup for my cluster that I can see something. I define an SSD storage class, which I use for CB later on, and I totally forgot what the service monitor is, but that's what we need as well. In the background, we can see that running. So it's currently creating the cluster. That normally takes a while, so I can explain you a couple of things in the meanwhile. So you see it's currently starting to be provisioned, but it normally takes a while. As soon as that's done, when I have the cluster, what I will do is I will install Kafka, and in this case, I just use the official Helm charts from Confluent in order to do that. In order to run that, you basically clone the repo. That's what I did. So that's already here. It's cloned. Then I copy the Kafka Connect values to that values file. Why do I do that? So that's basically this. I copy that here to that values file so we can see what's the diff. And it's relatively straightforward. So I basically, okay, I disabled things like registry, which I simply don't need to save a couple of pods. But the important thing here is instead of using the plain Kafka Connect, I use a Docker image from me. I explain what that is in a minute. And I think that's more or less it, right? So I basically want to use my own image. Why do I want to do that? You can find the image here in yeah, right. Kafka Connect CB Docker. So what you can see is that's the jar file for Kafka Connect CB. That's one Uber jar which I built from the connector. So we don't have yet a release Docker image of that. We will probably have that soon, but at the moment we don't. So I just extend the Kafka Connect one, set the connect the plugin path to include some folder where then I add that jar file to in that Docker image. And that means now I have Kafka Connect CB in the class path of the Kafka Connect instance, which is then started up in my Kubernetes environment, right? So that's that. Let's see how the cluster is doing. Okay, cluster is there. It's currently installing Helm. That might still take a bit. What we can already do is we can look into the cluster. Okay, that's probably quite boring. Let's look into what's going on in the cluster. And thank you, Internet. Um, let's quickly just look at my cluster. Thank you, Google. Right. So that's my cluster. Not a lot of things there yet. Um, hmm. Tilo created Helm. Let's see how that continues. It should actually work. Um, let's wait for that. So um, moving on, that means I will install Kafka with a Helm chart in a minute, which basically is just a Helm install. And then it installs everything you need for Kafka, including Zookeeper, Kafka itself, Kafka Connect, the one with CB on Kafka Connect CB on the class path. So that is that. And then, and that's the most interesting part actually, I just copied that from another project. So it's not totally laid out in a perfect way, let's say. Um, but I want to start CB. And for CB, and that's probably overkill for this project, but this is how we set it up. Um, we allowed it to have different configurations being benchmarked. So we have a project where we can say, hey, run this with the whatever, with 3 nodes or with 10 nodes or with 20 nodes and with 5 partitions or 500 partitions in order to really benchmark certain scenarios. That's what we have running internally. And I just copied it from there and said, okay, I'm just running like one simple test run here. And if you if you change this configuration, it will be actually used to set up your CB cluster in that small project. So in my case, I say, hey, run a cluster size of 5 with a replication factor of 1. So you might want to probably check for 3, for example, to be more realistic. A couple of threading things, and also the image. So I'm currently using a 0.21.1. If you want to use a different one, go for it. And then I also configure the starter. I come back to that in a minute, okay? And then what we use here is only Helm templating in order to create basically the configurations for Kubernetes, for CB, and the starter. So let's look at CB first. So it basically sets all these like partition counts, replication factor, um, the cluster size, and so on and so forth. So all these configurations are set in here, and then this is sent to Kubernetes in order to provision CB itself. And you can see that in the run single test shell script. So again, this is kind of not nice for this single run, but I just copied it and removed a couple of things. So I wanted to have something quickly, so that's why. So basically, what I do is I run helm template, so that's just generating the YAML file. It doesn't like run Helm for installation, just the templates. That will generate here test runs, examples. That will generate like final like a YAML file, which is then applied to Kubernetes. And here you can see everything like replaced as you would expect it. Okay, so that's the first step. What that shell script is doing. Then it's actually applying that one. I mean, you can do that manually if you prefer. Perfectly fine, fair. Do it manually. That's also good. So it applies CB, that starts up the CB cluster. Then we do a bit of a trick in order to wait for CB for all the nodes we define to come up, especially if you run big clusters. That might take a while because very often Google Cloud has to extend your cluster, has to allocate more resources, which normally takes really a bit. So if you run, what I love doing is like running cluster size of 48 or even bigger, and that might take a couple of minutes actually to start it up. Right, but still much faster than ordering hardware and mount them in the rack in your data center. So I'm still pretty happy of being able to do that. And then the next thing is I run the starter. The just the starter. I removed the worker. What's the starter? The starter is actually it's a small Java program. Do I have that open? Yes, a small Java program as a Spring Boot application packaged as a Docker container, obviously, and this is how I get it on Kubernetes. And what it does, it's really straightforward. It where am I? Hang on, that's not the starter anymore. I was confused, sorry. So what it does, it basically says it deploys a workflow definition to CB, right? And that's the workflow definition, from the ping pong example, right? So this is deployed on CB first, and then it just starts instances of that, right? And here, so new processes in the latest version. And then it counts how many of them it creates. I don't want to go into all the details how we do that. There are a couple of things why we do it that way. This might not fit what you want to test. Then you simply can adjust everything here, or you can use a different starter. You can write it in whatever Node.js or Go if you like. Feel free to change that. But I use that to quickly generate load or start workflow instances here. And this is actually run as soon as the Docker file comes up, as soon as that starter is started in Kubernetes. That's why, and that's probably already quite detailed, but if I'm here already, that's why I call it a batch. So it's a job. So that means when it starts up, it starts the Java program. The Java program starts to do load until basically some timeout is hit, which is per default 10 minutes, and then this ends itself. And then the Kubernetes pod is also ended. But it's fine because you say it's a job. If it's done, it's done. Okay. And then you have like whatever instances created. And this is more or less it. Let's see what my cluster is doing. Because we have to catch up a couple of things. So this looks pretty good actually. So what I do next is here I do my Helm install. As you can see, I'm quite prepared. Sorry for that. Not that prepared as I thought I am. So this now install. Sorry, I should have copied it. So that's what we do. Yes, of course, I do need that. So there we go. What that does is, and now in the background, you should see a couple of more pods coming up. basically Kafka Connect. And if you look into Kafka Connect, the small but important detail here is that you can see faster Google. That you can see. There is the pod. As soon as I go onto that, I basically see the container now. And if you look into the container, you will see that this is now my Kafka Connect, not the original one. Okay, so that's pretty good. That starts up Kafka, but that doesn't stop us from doing the other thing at the same time. So I now run a single test. Let's see if that works. I actually changed a couple of things a couple of minutes ago, but it should work. So what it does, it now creates CB. So it does basically a kubectl apply for CB. Really cool. Let's see. Right, there's CB. If it says unschedulable, I think what currently happens is that my cluster is getting extended. Let's see. Maybe you start with smaller cluster sizes. Okay, yeah, probably that's still too small. Let's see. But all of that normally takes a bit. I mean, that's pretty normal. He's still scheduling the other stuff, so we wait for CB to be scheduled. Actually, this script also waits for it to be scheduled, and then the starter is created. Something we can do in the meanwhile, let's open up another shell. Because what you can also do if you go to the Kafka or the Confluent Control Center, then you can also connect to that. It's not exposed as a service. Feel free to do that if you like, but I prefer, no, I want to go to the service, sorry. You could expose that via the load balancer, get a public IP, and so on and so forth, but I'm not in, sorry. This is one of them that like missing feature of setting the cluster like here on the global level and Google remembering it. That drives me mad. Why is there no service for my cluster? Should be there. Maybe it's still setting it up. Okay, now the cluster is unavailable. Let's see what's happening here. No. Let's see. Cluster. No, where's my cluster? Maybe that takes a moment. Upgrading cluster, yeah, that's what I thought. It's weird that it doesn't show that here, but that's what I said earlier on. That's kind of normal if you put a lot of workload on the cluster, it has to be made bigger. That will take probably a bit. As soon as that's there, we can also connect to like do a port forwarding and connect to Kafka Control Center. That's what I wanted to show. And then we can go to the service and see Grafana in action, and we can see that Camuna is doing something. But there's no way around. We have to wait for the cluster to become ready. And I will quickly pause the recording and continue as soon as it's there. Okay, here we go. Finally, my cluster is back. It was extended, so it's a bit probably bigger now. And here we are. CB is there. This should be probably recognized by this script. Yeah, and it started the starter, right? Wonder why I don't see that here. There it is. So this should actually run. Let's see. It probably gives me something on the console. I even forgot if I print something on the console. Probably not. Not that important anyway. I wanted to container logs. Let's see. Come on. The starter. Okay, I seem to have a problem with that still. Okay, shutting down. I have to double check, but somehow it does something. That's already good. Let's see what it does. And there are two ways of doing that. Let's quickly go here. If I go to the services, and again, it forgets the cluster. Oh, I hate this. Cluster. Come on. Oh, that's so bad. Cluster. Right, there we are. Right, then the first thing you can see, I do assign a load balancer IP for Grafana. Grafana, it should be admin. Oh, new password. Go for it. Come on. I don't care. Then you can go to the dashboard and actually import a new dashboard. Go away here. Oh, is it here? Yeah, create dashboard. No. Import. Right. Always. Right here, upload JSON file. Right. In that report, you find the CB dashboard, which is a good start to start with, because then you will already see certain things like how many events or events per second, or the completed job. This one is interesting, gRPC requests per second. This is how the client talks to it. Like you see that create workflow instance, deploy workflow, get the topology, resource exhausted. That's probably, so it seems that I resource exhausted means I just give too much load on it. We have back pressure. So I think this is currently like what I'm seeing here. So I have to reduce the load I'm putting into that. So that's this. And the other thing that's interesting is like the Kafka control center. And if I go there, I can make a port forward in order to see that. There we are. There are multiple ways of doing that. I always use the don't make me think one, where I use Google thingy here. You can use kubectl as well. That will work. And then I can go to localhost 8080 and see the control center, the Confluent one, where you should see all your brokers and topics. And if you go to Kafka Connect, basically the most interesting part here is if you hit on Add Connector, what you can see is that you have the CB source connector here in the class path. And this is basically where I'm currently at. So I haven't yet done the next steps. What would be the next steps? Let's quickly recap. So I now have to start really Kafka Connect and use the JSON config for that example. So if we go back to the Kafka Connect, so that's no, there's Kafka Connect, there's the example, there's the ping pong. There are two sync and source. So let's quickly copy them in our nice little benchmark projects. Kafka Connect config. Right, so go there. And there's a REST API to actually provision them and say, hey, this is my Kafka Connect source, my sync. they are basically defining the configuration for it. Where I'm basically using the thingy here, and I have to provide, and that should actually work in the cluster. So that's more about the topic, but the topic should probably be auto-created, right? Okay, I hope so. So start Kafka connect with the JSON config. That's something I haven't yet done, and I actually have to finish now. So I wanted to record to the point where I am at the moment, so I can probably pick it up from there. And I might add another video where I do the rest. And as soon as you do that, and we already have started a lot of like workflow instances, as soon as you start the source, where is it? Where is it? Where is it? So if you go back to the workflow we're currently having. There it is. So if you start the source, you should have a lot of workflow instances currently here waiting. And as soon as you start the source, it will catch them more or less all and push them to a topic in Kafka. And if you don't start the sync, they're waiting in that topic. And that should give you an indication like how probably even how quickly you can do that and how much throughput you can reach and if it works and so on and so forth. And then the next thing you can do is you can probably shut that down or keep it going and start the sync, and that should like correlate them all here, and the process moves on. And I think that's kind of the environment where you can now start playing around with different things like adding payload, doing a different starter, having everything running, and probably only measure some throughput in terms of like whatever running workflow instances, if or whatever you want to do, right? So there are a couple of possibilities here. Um, yeah, that's it for now. I might pick it up again. Good luck. Bye bye.